Now we will continue about this about the descriptive statistics and its second part. Ratio scale, the most detailed and objectively interpretable of the measurement scales. Interval scale with an absolute zero. It has a true 0 point, absence of property being measured as well as equal intervals. Example, height, weight, money, age, time, speed, class size. Now we'll be talking about collecting the data. While deciding about the method of data collection to be used for the study, the researcher should keep in mind two types of data, that is primary and secondary. The primary data are those which are collected afresh and for the first time, and thus happen to be original in character. The secondary data, on the other hand, are those which have already been collected by someone else and which may already have been passed through the statistical process. The methods of collecting primary and secondary data differ since primary data are to be originally collected, while in case of secondary data, the nature of the data collection work is merely that of compilation. Data presentation. The first step in summarizing data is to organize the data in some meaningful fashion. Data should be presented in such a way that data should become concise without losing the details, arouse interest in the reader, become simple and meaningful to form impressions, become helpful in further analysis. There are two main methods of presenting frequencies of a variable: frequency distribution tables and graphs and diagrams. Frequency distribution tables. These are used for presentation of continuous data. It is the most convenient and commonly used method in which raw data are organized in columns and rows. In this distribution, the number of observations of frequencies are displayed according to different group or different values of the variable. It presents the data very concisely, giving information at a glance. Class interval should be equal throughout the table. Now we can see here that the class interval of students or pupils getting marks between 0 to 10 is 4, and the frequency is also 4. Graph and diagrams. Although frequency distribution is an effective way to organize and present data, graphs can convey that information more effectively. They provide a visual method of examining quantitative and qualitative data. They help us to have a real graph of the overall picture rather than details. Graphs and diagrams can be classified according to the type of data which they are used. The common graphs and diagrams used for presentation of qualitative data are discrete or counted data, bar graphs, pie charts, pictograms, and spot maps. Whereas presentation of quantitative or interval ratio variables is done through histogram, frequency polygon, frequency curve, line chart, cumulative frequency polygon, scatter or dot diagram, stem and leaf plot, and box whisker plots. Bar graphs. A bar graph is a 2 or 3-dimensional diagram in which categories of nominally or ordinally scaled data appear on the x-axis and the corresponding frequencies appear on the y-axis. The height of a vertical bar indicates the number of observations that fall into a class interval. Bars may be drawn in ascending or descending order of magnitude or in the serial order of events. When two sets of data with an unequal number of observations are being compared, the height of a vertical bar should represent portions or percentages. Bar diagrams can be further made by 3 types. Simple bar charts, bar chart, where one group or category is denoted using single rectangular bar. Multiple grouped bar chart. Grouped bar charts are a way of showing information about different subgroups of the main categories. For example, a grouped bar chart can be used to show the data related to total number of decayed, missing, and filled teeth among male and female members of a sample. Component stacked bar chart. Stacked bar charts are used to display information about the subgroups that make up the different categories. But in this type, the bars representing the subgroups are placed on top of each other to make a single column. The overall height of the bar shows the total size of the category, whilst different colors or shadings are used to indicate the relative contribution of the different subgroups. Pie charts. This is graphical depiction of data as segments of a circle. The total represents the complete circle or pie. The central angle of each slice is proportional to the size of that part to the whole data. Spot maps. These maps are prepared to show geographical distribution of frequencies of characteristics. They are very effective methods of portraying incidence and prevalence rate of any health-related event. Although in today's computer era, their use is declined. Histograms. It is a graph that uses continuous vertical bars to display the frequency of the data, unless the frequency equals 0, contained in each class. The heights of the bars equal the frequency and the bases of the bars lie on the corresponding class. Frequency polygon. It is obtained by joining the midpoints of all erected rectangles of a histogram by means of a straight line while replacing the rectangles. It gives a polygon that is a figure with many angles. Although histograms generally are recommended for presenting frequency distributions, the shape of the distribution is seen more easily in a frequency polygon than in a histogram. It is also used when sets of data are to be illustrated on the same diagram, such as birth and death rates, birth of diabetic and non-diabetic, etc. When the number of observations is very large and class interval is reduced, the frequency polygon tends to lose its angulation, giving place to a smooth curve known as frequency curve. Line charts. This is a frequency polygon presenting variations by line. The frequency is placed along the vertical axis and the class midpoints are placed along the horizontal axis. These points are connected with lines. It shows the trend of an event occurring over a period of a time rising, falling, or showing fluctuations such as oral cancer deaths, infant mortality rates, case of leprosy from year 2006 to 2016. Scatter diagram. The scatter plot visualizes a correlation between two variables x and y. Example, weight and height. Individual data points are represented in two-dimensional space where axes represent the variable x on the horizontal axis and y on the vertical axis. The graph can show no relationship between the variables or a positive or negative association. The graph also shows whether the relationship is linear or non-linear. When there is a linear relationship, a line of best fit can be drawn. Stem and leaf plot. A stem and leaf plot is a display that organizes data to show its shape and distribution. In a stem and leaf plot, each data value is split into a stem and a leaf. The leaf is usually the last digit of the number and the other digit to the left of the leaf form the stem. A stem and leaf plot resembles a histogram turned sideways. The stem values could represent the interval of a histogram, and the leaf values could represent the frequency of each interval. One advantage to the stem and leaf plot over the histogram is that the stem and leaf plot displays not only the frequency for each interval, but also display all of the individual values within that interval. Box whisker plots, a geographical representation of the minimum, first quartile, median, third quartile, and maximum. This plot gives an idea of the distribution of the data. It is especially useful to identify differences in variability between groups and identify outliers. These are the references that have been used in this presentation. Thank you.